There's a moment every morning, in factories scattered across the country, when something almost magical happens. The lights flicker on, machines hum to life, and within minutes, thousands upon thousands of golden rings begin their journey from raw ingredients to the glazed perfection you find in your local shop. But what you're about to witness isn't the small batch artisan process you might imagine. This is industrial baking at a scale that defies belief, where a single facility can produce over 1 million donuts in a 24-hour period. Step inside one of these high-tech temples of sweetness, and you'll discover a world where chemistry meets engineering, where centuries-old baking traditions collide with cutting-edge automation, and where the simple donut reveals itself to be anything but simple. The air is thick with the scent of frying dough and sugar, but beneath that familiar aroma lies something far more intriguing: a precisely choreographed symphony of conveyor belts, robotic arms, and computer-controlled systems working in perfect harmony. Most people have never seen what happens behind those factory doors. They've never witnessed the moment when liquid batter transforms into a perfect ring, or watched as hundreds of donuts cascade through a waterfall of glaze in a single minute. They don't know about the engineers who've spent years perfecting the exact angle at which a donut must flip in midair, or the food scientists who can predict the internal temperature of a frying donut to within half a degree. This is that hidden world, and once you see it, you'll never look at a donut the same way again. The donut, believe it or not, has been the subject of more patents than almost any other baked good in history. Since the early 20th century, inventors have filed over 300 patents related specifically to donut production, covering everything from the shape of the cutter to the optimal frying temperature. The reason? Creating the perfect donut at scale is exponentially more difficult than making one in your kitchen. In a modern factory, the difference between a light, fluffy donut and a dense, oily disappointment can come down to variables measured in fractions of seconds and millimeters. Consider the hull itself, that iconic empty center. It wasn't originally designed for aesthetics or easy dunking. The hull exists because early bakers discovered that dough fried in large chunks wouldn't cook evenly. The center would remain raw while the outside burned. By removing the center, they created a shape that allowed heat to penetrate uniformly. Today's factories have turned this simple solution into a science. Engineers have calculated that the optimal hull-to-donut ratio is approximately 1 to 3.5. Too small, and you risk uneven cooking. Too large, and the structural integrity fails during the glazing process. Here's something that will surprise you. The average factory donut spends less than 90 seconds actually frying. That's it. 90 seconds to transform from pale, raw dough into a golden brown masterpiece. But those 90 seconds are so precisely controlled that the oil temperature is monitored by sensors taking readings every tenth of a second. The oil itself is a carefully engineered blend, often containing palm oil, soybean oil, and proprietary additives that prevent breakdown at high temperatures. In a single day, a medium-sized donut factory will use approximately 800 gallons of frying oil, which is filtered continuously through micron-level screens to remove particles and extend its usable life. The oil is never simply discarded. Modern facilities recycle used frying oil into biodiesel, animal feed supplements, and even industrial lubricants. Some factories have achieved near zero waste in their oil management systems. The yeast used in raised donuts is another marvel of modern food science. Unlike the packets you buy at the grocery store, industrial bakeries use liquid yeast cultures that are kept alive in temperature-controlled tanks. These cultures are descendants of strains that may be decades old, carefully maintained and propagated like sourdough starters. The yeast is so active that if left unrefrigerated for more than 30 minutes, it would begin consuming sugars at an uncontrollable rate, producing carbon dioxide so rapidly that the dough would overproof and become unusable. Factory bakers refer to yeast as a living ingredient, and they're not exaggerating. In the proofing chambers where dough rises before frying, the yeast population in a single batch of dough can number in the trillions. Each microscopic organism is consuming sugar and producing the gas bubbles that give donuts their characteristic texture.
As you can see, our state-of-the-art automation process ensures the highest quality standards throughout the production line.
The glazing process is where factories truly showcase their technological sophistication. Traditional glazing involved manually dipping donuts into bowls of sugar glaze, a labor-intensive process that resulted in inconsistent coating. Modern factories use what's called a glaze curtain or glaze waterfall, where liquid glaze flows continuously over a stainless steel curtain while donuts pass underneath on a conveyor belt. The glaze is maintained at exactly 95 degrees Fahrenheit, a temperature discovered through thousands of tests to be the perfect balance between fluid enough to coat smoothly and thick enough to adhere properly. If the glaze is even 3 degrees too warm, it runs off. 3 degrees too cool, and it clumps. The factories use infrared sensors to monitor glaze temperature in real time, making micro-adjustments every few seconds. What's even more impressive is the glaze recirculation system. Any glaze that doesn't stick to the donuts is collected in troughs below the curtain, filtered, reheated to the precise temperature, and pumped back to the top. A well-designed system wastes less than 2% of the glaze it produces. Chocolate-covered donuts present an entirely different challenge. Chocolate must be tempered, a process that involves carefully controlling the crystallization of cocoa butter to achieve that characteristic snap and shine. Factories use tempering machines that cost upwards of $50,000, capable of processing hundreds of pounds of chocolate per hour while maintaining the exact temperature curves required for perfect temper. The chocolate coating you see on a factory donut has likely been through a heating and cooling cycle that's been refined over decades of research. And tempered chocolate would appear dull, melt at room temperature, and develop a white bloom within days. Properly tempered chocolate can maintain its appearance and texture for months. Then there's the filling. Cream-filled, jelly-filled, and custard-filled donuts require injection systems that can deposit exactly the right amount of filling into the center of each donut without breaking through the outer shell. Modern filling injectors use pneumatic pressure systems with needle tips that are precisely calibrated for different donut densities. The needles pierce the donut, inject the filling in less than half a second, and withdraw, leaving only a tiny mark that's usually hidden by glaze or toppings. The machines can fill up to 300 donuts per minute, and they're so accurate that the weight variation between filled donuts is typically less than 2 grams. The fillings themselves are engineered for stability. A factory jelly filling isn't the same as the jam in your refrigerator. It contains stabilizers and thickeners that prevent it from leaking out of the donut during transport and storage, yet it still feels natural and fruit-forward when you bite into it. Quality control in a donut factory is obsessive. Every batch is tested for moisture content, density, color, and structural integrity. Factories use devices called texture analyzers that measure the exact force required to compress a donut by a specific amount, ensuring consistency across millions of units. Color is measured using spectrophotometers, instruments that can detect variations in browning that the human eye couldn't perceive. If a batch falls outside the acceptable range on any parameter, it's rejected. In some facilities, rejected donuts are ground up and used as animal feed or composted. In others, they're sold to discount outlets at a fraction of the price. The rejection rate in a well-run factory is typically below 3%, a testament to how precisely these processes are controlled. Speed is another factor that separates factory production from artisan baking. A skilled baker working by hand might produce 50 to 100 donuts per hour. A single production line in a modern factory can output 10,000 donuts per hour. The fastest lines in the world, found in facilities supplying major retail chains, can reach 15,000 per hour. At that speed, the donuts are moving so fast on the conveyor belts that they appear as a blur to the human eye. The entire process from mixing to packaging can take as little as 45 minutes, meaning a donut could go from flour and water to a sealed box in less time than it takes to watch a television show. From the moment flour arrives at the factory in massive silos holding tens of thousands of pounds, to the instant a finished donut slides into a retail box, every single step has been analyzed, optimized, and automated to a degree that would astonish the bakers of even 50 years ago. The factories run 24 hours a day, 7 days a week, pausing only for maintenance and deep cleaning. The machines are built to withstand the heat, humidity, and constant motion of continuous operation. Conveyor belts are made from food-grade materials that can be sanitized at high temperatures. Fryers are constructed from stainless steel that resists corrosion from hot oil. Mixing bowls are sized to handle batches measured in hundreds of pounds, with industrial mixers powerful enough to blend thick dough that would burn out a home mixer in seconds. The raw materials that fuel this industrial ballet arrive in forms most home bakers would barely recognize. Flour comes in bulk tanker trucks and is pneumatically transferred into storage silos that can hold up to 40,000 pounds. These silos are climate-controlled to prevent moisture absorption and maintain consistent flour characteristics year-round. Sugar arrives in similar fashion, stored in separate silos with their own handling systems. Eggs don't arrive in cartons but in liquid form, pre-pasteurized and stored in refrigerated tanks. A single tank might hold the equivalent of 10,000 eggs, ready to be pumped directly into mixing systems. Milk and cream arrive in refrigerated tanker trucks, transferred into stainless steel storage tanks that maintain temperatures just above freezing. The scale is difficult to comprehend until you see it in person. The manufacturing process begins in the mixing room, where ingredients are combined in planetary mixers that can hold up to 500 pounds of dough at once. These aren't the stand mixers you have at home, scaled up. They're purpose-built machines with multiple mixing attachments that can be swapped depending on the dough type. For raised doughnuts, which require yeast, the mixing process is gentler to avoid damaging the gluten structure. The mixer runs at lower speeds, incorporating as slowly and evenly. For cake doughnuts, which use chemical leaveners like baking powder, the mixing is more aggressive, creating a batter that's smoother and more uniform. The mixers are computer-controlled, following recipes programmed down to the second. When the mixing cycle completes, the dough or batter is transferred to holding tanks or directly to the production line. For raised doughnuts, the dough moves to a sheeting and cutting station. Industrial dough sheeters use heavy rollers to flatten the dough to a precise thickness, typically around ½ an inch. The dough passes through multiple sets of rollers, each reducing the thickness incrementally to avoid tearing or overworking the gluten. Once sheeted, the dough moves under a cutting mechanism that stamps out donut shapes at incredible speed. These cutters use sharp-edged rings that punch through the dough, creating the outer circle and inner hole simultaneously. The cut donuts are placed on screens or trays, and the scrap dough between the cuts is collected, reworked, and fed back into the sheeting process. Waste is minimal because the engineers have calculated the optimal spacing between cuts to maximize yield. The cut donuts then enter proofing cabinets, enclosed chambers where temperature and humidity are precisely controlled. Inside these cabinets, the yeast goes to work, consuming sugars and producing carbon dioxide that causes the dough to rise. The proofing process typically takes between 20 and 40 minutes, depending on the recipe and desired final texture. During proofing, the donuts can double in size. Sensors inside the cabinets monitor the rise, and in some advanced systems, computer vision cameras actually watch the donuts and determine when they've reached optimal proof. Underproofed donuts will be dense and heavy. Overproofed donuts will collapse during frying. The window of perfection is narrow, and hitting it consistently is what separates good factories from great ones. From the proofer, the donuts move directly to the fryer, one of the most critical pieces of equipment in the entire facility. Industrial donut fryers are marvels of thermal engineering. They're essentially long, narrow tanks filled with oil, heated by gas burners or electric elements that maintain the oil at exactly 365 degrees Fahrenheit. The donuts are loaded onto a conveyor system that submerges them in the hot oil. As they fry, they naturally flip over halfway through, ensuring even browning on both sides. This flip isn't random. The conveyor is designed with specific angles and speeds that cause the donuts to rotate at precisely the right moment. The entire journey through the fryer takes about 90 seconds. As the donuts emerge from the oil, they pass through a draining section where excess oil drips off, then move onto a cooling conveyor. Cake donuts follow a different path. Instead of being cut from sheeted dough, cake batter is deposited directly into the fryer using a specialized machine called a donut dropper. This device has a hopper filled with batter and a series of plungers that push measured amounts through ring-shaped nozzles. The batter drops directly into the hot oil in perfect rings. Cake donuts fry at a slightly lower temperature than raised donuts, around 350 degrees, and they fry faster, typically 60 to 70 seconds. They don't rise from yeast but from chemical leaveners that react with the heat, creating a denser, more crumbly texture than their raised counterparts. After frying and cooling, the donuts enter the finishing area. This is where the magic of glazing, icing, and topping happens. For glazed donuts, the glaze curtain system coats each donut in a thin, even layer of sweetness. For iced donuts, a different system applies thicker, opaque icing that sets firm. Toppings like sprinkles, nuts, or coconut are applied immediately after glazing while the surface is still sticky. These toppings are dispensed from hoppers positioned above the conveyor, releasing precise amounts as each donut passes beneath. Some facilities use vibrating feeders to ensure even distribution. Others use air jets to blow toppings onto the surface. The goal is always the same: consistent appearance across thousands of units. Filled donuts require an additional step. After cooling but before glazing, they pass through the filling injection station. The pneumatic injectors pierce each donut from the side, deposit the filling, and withdraw in a fraction of a second. The filled donuts then continue to the glazing or icing stations just like their unfilled counterparts. The coordination required to keep all these processes running simultaneously is staggering. A single production line might have raised donuts, cake donuts, and filled donuts all moving through different stages at the same time, each requiring different temperatures, timings, and handling. Quality control happens continuously throughout the process. Workers stationed at various points along the line visually inspect the donuts, removing any that don't meet standards. Automated systems also play a role. Metal detectors scan every donut to ensure no foreign objects have contaminated the product. Weight checkers verify that each donut falls within acceptable parameters. Temperature probes monitor the fryer oil and the internal temperature of finished donuts. In some facilities, X-ray systems can actually see inside filled donuts to verify that the filling is properly centered and that there are no voids or air pockets. The final stage is packaging. Donuts move from the finishing area to the packaging line, where they're sorted and placed into boxes, bags, or trays depending on their destination. Retail boxes are typically filled by hand, with workers arranging donuts in appealing patterns. Bulk packaging for food service customers is often automated, with robotic arms or mechanical pushers loading donuts into larger containers. The packaging materials themselves are specifically designed for donuts. Boxes have ventilation holes to prevent moisture buildup that would make the donuts soggy. Some premium packaging includes moisture-absorbing pads. Once packaged, the donuts are sealed, labeled with production dates and nutritional information, and moved to shipping areas where they're loaded onto refrigerated trucks for distribution. The entire facility operates under strict food safety protocols. Surfaces are stainless steel or food-grade plastic, easy to clean and sanitize. Workers wear hairnets, gloves, and in some cases, full protective clothing. The factory is divided into zones with different cleanliness requirements, and movement between zones is controlled to prevent cross-contamination. Air handling systems maintain positive pressure in production areas, preventing outside air from entering. The floors are sloped toward drains, allowing water and cleaning solutions to flow away during sanitation procedures. Every piece of equipment is designed for easy disassembly and cleaning. At the end of each production shift, or at scheduled intervals, the entire line is shut down and cleaned from top to bottom. The logistics of running a donut factory are as complex as the production itself. Raw materials must arrive on schedule, in the right quantities, and at the right quality. Finished products must ship out quickly because donuts have a limited shelf life, typically 3 to 5 days. Factories use sophisticated inventory management systems that track every ingredient from arrival to incorporation into finished products. They use predictive algorithms to forecast demand and adjust production schedules accordingly. During peak seasons like holidays, production can increase by 50% or more, requiring careful planning to ensure adequate supplies and staffing. Now you understand why that donut in your hand represents far more than flour, sugar, and oil. It's the product of decades of engineering refinement, millions of dollars in specialized equipment, and the coordinated efforts of food scientists, mechanical engineers, and skilled workers. It's a small miracle of modern manufacturing, and factories around the world are producing them by the millions every single day. But if you think the technology behind donuts is impressive, wait until you see what happens inside an ice cream factory. The video that just appeared on your screen will take you into a world of sub-zero temperatures, where liquid cream transforms into frozen perfection through processes that seem to defy physics. You'll discover why ice cream made in a factory is smoother than anything you can make at home, and you'll see machines that can fill, seal, and package at seconds. Don't miss it. And while you're here, hit that subscribe button so you never miss another behind-the-scenes look at the factories that make the food you love. Before you go, I have a question for you. What surprised you most about donut production? Was it the 90-second frying time, the glaze curtain system, or something else entirely? Drop your answer in the comments. I read every single one, and your feedback helps me decide what factories to explore next. Thanks for watching, and I'll see you in the ice cream factory.